Charles, can you try speaking? I don't know if we can hear you. Okay, awesome.
Is it,
You want me to?
what channel is it on? Is it here?
Okay.
Yeah. Do you want me to mute myself or just leave everything, let you all control the volumes and things like that?
Yeah, just let us control volumes. You're fine.
Okay.
Awesome.
It's only when...
Oh, good. At least you're there.
Mm-hmm.
Yay.
I love it. I love it. I'll retweet that later.
Dada, do we need to do mic checks on everybody?
Yeah, please.
Who do you want first?
Athena, can you speak for me, please?
Hello, my name is Athena Brensberger. I am super excited for today's interview and had a great Uber driver this morning. His name is Yuri. And I tried to speak to him about Yuri Gagarin, but he actually didn't speak too much English, so that didn't really go too far.
Thank you.
Yeah.
Carry on.
That's hilarious. I did not know how to pronounce your last name, so I'm glad that you did that for me. Maybe you just need to speak more Russian? Just throwing that one out there. Not going to make you speak Russian, but still.
Thank you.
Hi, my name is Jade. I come here often. I stand next to Carrie Ann. And
Thank you.
thank you.
Awkward. Sarah.
Try that again.
Okay. Oh, was I off? I was off. Mm-hmm. Thank you. I was saving battery is what I was doing.
Obviously.
That is, the...
Good, thank you. Charles, can I get some audio from you? What did you have for breakfast?
Sure. When in the course of human events, we, the people, in order to form a more perfect union, establish justice equals MC squared. The world
that's
is your
fantastic.
oyster.
Fantastic. Awesome. Thank you.
Okay.
I love that piece of fiction.
Jesus. So good. Do you want a cup for that, Judah?
Who, me?
Yes, you.
Oh, I'm okay. No, I'll just sip, when I'm done.
All right.
I'll probably burn my tongue if I drink on camera.
I just burned my tongue.
Yeah! Then I'd have an excuse to say that. I just burnt my tongue.
I did that when I was out backpacking a couple months ago. I poured coffee right into my my coffee cup, straight from having it boil on the fire, and then I just immediately just didn't even think about it. I just immediately put it.
Who would have thought fire makes things hot?
I didn't know.
Who knows?
So good.
I'm hearing a lot of breathing.
So I'm going to follow the script. So I will turn to Sarah first and then to Miss Jade.
Okay.
Just FYI.
Oh man, chat is having fun.
Chat is foobarred beyond.
Yeah.
Yeah, so we're just gonna...
I enjoy when people know that acronym.
Wrong way.
Let's switch over to AIM.
Well, except that, I went to just reiterate the acronym. I was like, FUBAR, beyond all repair. Never mind.
Yep.
All right, we're ready when you are.
Okay.
Because I have a other name.
Do a show report. I just do I have a template. If there's something I need to jot down.
Okay. You need me out of the way? Okay.
Snuggle in.
This shouldn't be plugged in. Sorry, kids.
Dance body.
Big and warm.
If I could get this hot steak that's running through my head out, that would be
Hot
very...
steak?
Oh,
Yes. You have a hot steak?
Yeah.
In your head?
This conversation.
You ever get those headaches?
Oh, headache.
Jade wasn't here for the...
I was thinking of steak.
Yeah, no, I was thinking steak.
Yeah.
Like a vampire.
Yeah.
Okay, I thought you meant like a
Spike.
nom, 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 nom. Sorry.
Buffy
I
moment.
was like, you got steak on the mind? Me too.
Now I do.
Yes.
Okay, BBQ. Let's go mourn the loss of South Korea's soccer team. It's okay.
What are we holding for?
Ben?
Kick him off and hold.
Don't blame that on me.
You brought it.
To be fair, I was drugged when we got married.
Where's the lie?
Which in 3 more days will be 17 years.
Holy moly!
And then we can divorce.
Because you've reached that,
Right.
you're fully vested.
Right. I am fully vested. As soon as you sign it,
California doesn't have to sign.
really? He doesn't have to sign?
Wow.
Wait, do I have to sign?
Cold-hearted.
Don't do that to us.
Can neither one of us sign?
If either of you files
Yeah.
and it goes uncontested for 6 months,
Yeah?
then it's official.
Early Christmas present. This is great. Early Christmas.
Oh, it's almost half Christmas, so it's okay.
Right, that's what I'm saying.
Yeah.
I have no idea what the chat room is doing or thinking right
I
now.
know,
So
I know.
everyone's probably like freaking out really
It
badly.
isn't working.
I'm going to give the chat room 60 more seconds. If we can't get the chat online in 60 more seconds, we're going to dump that part of it. We're going to move everyone to the regular chat.
Okay.
And then that's how we'll run the show.
Copy.
Got it.
Let's just give it a minute and see if you can get it back up.
Oh, God.
That's what we're waiting for. We're waiting for chat.
Something happened to the chat.
Yes, it does not like us right now, which is quite sad.
No.
Well, I'm sure the people in the chat like us. It's just,
We just can't
Yeah,
take
sure.
Saturday morning
right?
to harangue us over anything.
Hey, and sometimes, in some cases,
Harangue.
this is Sunday morning. For some people,
Oh,
Or
that's
this
even
is- this is
more
your
dedicated.
or
look at
Saturday
that.
nights.
So it's all right
Saturday
for fighting.
Yeah, that's right. So,
I knew you were going for that joke.
yep.
Had to jump on the anachronistic bandwagon.
Nom, 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 nom.
Yeah, it looks like the regular chat is.
Regular chat's up.
Yeah.
Trying to
Jared.
use regular chat. It breaks social integration.
Yeah.
What?
What the deuce?
You sprouted arms out of your shoulders.
Backwards arms.
Hey!
Jade, you have so many arms.
Do this.
Jade Shiva.
Down.
Big fan of practical effects.
Yes. They just last longer.
All right, this isn't going to be a quick fix. So, everyone just go to chat.tmro.tv. Don't say the rest of it out loud, but that's everything that you want. The rest of it, you get rid of in your bar if you haven't already done that yet.
Hold it.
Cool. You're good?
You're
Dada?
fine.
Yeah.
Yep.
We'll probably crash this thing.
And yeah.
Right.
I'll try for next week.
Right.
I mean, yeah.
Who gets custody of Jared?
Ben does.
We split him in half.
Okay, got it.
Solid
Yeah.
style.
Here, I just got that fixed.
Okay, let's do this.
Right down the mohawk.
Everybody ready?
Yep.
Here we go.
What are you breaking?
All the things.
Welcome to tomorrow. I am Carrie Ann, and I will be your Capcom. The rest of the crew today is Sarah, Jade, and Athena. Now, Miss Sarah, what do you have first for us?
Oh, let's see. Einstein is, in fact, a genius.
Hold, restart.
Restarting.
That was bad.
I know. My fault. My bad. My bad.
That was terrible.
No, it was me. I had the wrong lower thirds. Sorry.
I'll actually say that.
Welcome to tomorrow. I am Carrie Ann, and I will be your Capcom of this rowdy crew. The rest of us, I have a Sarah, a Jade, and Athena. Now, Sarah, what do you have first for us today?
Einstein really is a genius.
And Jade?
Black hole in the jets.
So good. I was wondering how you were going to do that. And then on the observation deck, Miss Athena has an interview.
Yes, I will be interviewing Dr. Charles Liu from the American Museum of Natural History on observational galaxy evolution.
Perfect. And then this all-female crew will come back together at the end to go over your questions and comments about the last show. But this is tomorrow, Orbit 11.25.
Good morning. How's everything up in the sky? Stand by.
Now, before we jump right into all of the things that we have to say, I want to make sure I give a huge thank you to our Escape Velocity citizens. These are the people who have contributed $10 per episode or more. They get free worldwide shipping in our Tomorrow swag store. They get voting rights and upcoming roundtable discussions, which is really kind of funny because we should have one of those soon. They also get early access to our Escape Velocity Discord channel, and so much more, honestly. If you are interested in becoming a citizen of Tomorrow at any level, please head on over to patreon.com/TMRO. And I know I said just before we get into things, and now I'm going to say another just before we get into launches. You will notice we do not have a space mic. He is in the chat room, though, and he says, it's been a long time since I've watched live, LOL. Yeah, I'm guessing like 6-7 years or so, Mike. So, but thank you for joining us in the chat room. We appreciate your presence nonetheless. So, Miss Jade, do your best Mike impression.
Oh, and, let me get 2D real quick.
Yes, and then we had a Russia launch. I was going to say a space launch. That doesn't help anybody.
Launch.
So what happened? Tell me more about it.
Well, first of all, Mike, please now exit the chat and come back in about 5 minutes. Okay. So yeah, Russia actually recently launched a Soyuz 21B rocket that's carrying a new replenishment satellite for its GLONASS navigation system, and this is actually the 56th mission to do so. So they've had a few tries.
So peaceful.
And there it is.
Until the sound hits the camera.
You know those Russians, they have very nice and silent rockets. It's crazy how they've been able to engineer that. Just kidding, that's not a thing. So the GLONASS M number 56 satellite departed from the Plesets, there you go, Cosmodrome at approximately 21:30 UTC last Sunday, June 17th, with a Frigate M upper stage transporting the Uragan M number 756 spacecraft into orbit.
Obviously.
Duh. If you didn't know that, well, it ejected its four strap-on first stage boosters around 2 minutes into the mission, followed by the release of the payload about 2 minutes later.
Cool.
So you're probably wondering, GLONASS, what's GLONASS? Well, GLONASS is Russia's version of the GPS. It stands for Global Navigation Satellite System. 24 satellites comprise the GLONASS constellation, and although coverage isn't quite as strong as America's GPS, when you pair it together, both systems greatly increase accuracy in coverage. This particular satellite will actually help restore the GLONASS system back to its full strength, allowing it to provide worldwide coverage. The GLONASS M satellite will replace an older GLONASS satellite that was deployed back in 2009, having lived out its about 7-year service time, which is the average lifespan for these satellites. So this new addition will actually help improve radio transmission to the satellites, making it less corruptible, and again, improving the overall constellation system. And, hey, look, now when you get those fancy smartwatches, if you select the GPS plus GLONASS setting, you know what? The government is just going to know exactly where you're standing, what direction you're facing. They'll know what you had for breakfast.
I was saying, will they also give me accurate time?
Yes.
Yes?
Yes.
Beautiful.
Timing as well, if you're into that.
Right, because
some of you accurate time
may have noticed on our Twitter account lately, some people have been tweeting about the time of the show in coordinated Earth time to be differentiated from coordinated Mars time, which is in fact very, very different.
Awkward.
So it would help me, I would believe, to have GPS/GLONASS also /coordinated Earth time, knowing exactly where and when I am at any given point in time.
Throw some sidereal in there as well.
Are we going to need galactic time?
Oh, probably.
Always.
Yeah.
Probably.
And marine time.
Yes.
Okay, cool.
Maritime.
Maritime, yes.
Sarah, I feel like we already knew that Einstein was a genius.
Yeah.
Is there does he get a new patch for this one? Like, what's happening here?
It is yet another gold star on the theory of general relativity.
Okay.
All right, so in science, there is no such thing as just a theory. Because to be a theory, you have to have earned that title.
Oh.
Okay, so general relativity has done it yet again. Researchers from the University of Portsmouth and the Institute of Cosmology and Gravitation have used Hubble data and information gathered from the European Southern Observatory's Very Large Telescope to test general relativity on a galactic scale more precisely than ever before.
Nice.
Okay, the researchers used a prediction of general relativity called gravitational lensing. Yes,
that's a beautiful.
Yes, it's to determine that they use that to determine the mass of the nearby galaxy. Brace for it. ESO 325 G004, henceforth to be known as E325.
Thank you. Man.
Right?
Yes.
Now, nearby with this is extremely important because galaxy 325 is only about 500 million light years away. And for scale, Andromeda is 2.5 million light years away.
So this is way closer then.
Oh, no, it's way farther.
Way farther. Oh,
it's
God,
way farther.
500 million. So sorry.
No worries.
I'm looking at your script and I still can't do this math. This is why I have you. Okay.
All right.
Thank you.
So, farther than Andromeda, but not billions and billions of light years away, which is awesome. Because, okay, so the backstory. Gravitational lensing is an observable result of a massive object like a galaxy that is sitting between us on Earth and a distant light source. For this, we're going to call it a quasar.
Gotcha.
All right. So the mass of the galaxy between us and the quasar bends space around it. And light from the distant quasar travels on what that light would think is a straight path through space. Except, okay, light can't curve itself to counteract the curvature of the space that it's driving through. So what happens is it follows the curve of space itself around the massive body between the quasar and us. Okay, so using that, we can calculate the mass of the galaxy by observing how much the light from the quasar was bent.
Gotcha.
Cool.
As Prismara
All right.
in the chat room says, does this lensing make me look fat? I'm starting to feel that way right now.
It would make you look ringed. You would become an
Round.
Einstein ring, but
Nice.
we would know exactly how much you weighed. So,
So yes and no. All right, cool.
Right.
That's really cool. All right.
okay. So if you're with me so far, this study, the scientists needed a galaxy that was nearby so that they could measure the mass in two different ways. They could test the theory. Okay. So with E325, it was close enough for us to take it had a lensed galaxy behind it, so we could measure its mass that way. Using Hubble images, we used the lensing around E325 to calculate its mass. And then we took the images from VLT and measured the motions of stars in 325, and that's the key. It had to be close enough for us to measure the motion of stars inside the galaxy doing the lensing. Okay.
Interesting.
Yes. And now, with that, the numbers matched.
Nice.
Yes. Okay, so the mass of the object as predicted by general relativity and the mass of the object as dictated by Newtonian physics, how massive that body has to be to keep those stars in orbit, matched within 9%.
And that's so nominal is one of those terms you
Yes.
hear a lot in rocketry, right? Like everything's nominal. This is nominal,
Yes.
nominal, and nominal. I think in layman's terms, you kind of think of being as normal. Nominal equals normal, and it doesn't
Yes.
exactly equal per se, but that's to say that that the area in which there could be an error is small enough that we almost don't care.
Right, and especially when you're dealing with such huge numbers, 9% is
really, really tiny.
So small, and it's just fantastic to
So
be able to measure that.
That's awesome, and that's almost to be expected then at that point. Is that correct?
Yes, yeah. It's a theory.
It's a.
Only a theory, guys. Calm
Oh,
down.
I love it. I love it. That's awesome. That's really, really cool.
Yeah.
Nice. There's a joke in there somewhere. I'm just gonna skip right over it. Though.
Well,
Yes.
Yes. So, Miss Jade,
hi.
Benny and the Bens, as my husband likes to sing to this song.
Of course he does.
because of course he does. Black hole and the jets.
Yeah. Well,
what are we doing? What's
my
going
original
on?
name was Black Hole Nom Nom, so I'll just throw that out there.
Nice.
But basically, this is actually pretty cool and exciting. For the first time ever, researchers have been able to track and image the violent aftermath of what happens when a poor, helpless star wanders a little too close to big, bad, supermassive black hole beyond its event horizon, and they've actually been able to track the evolution of a jet of that black hole spewing those stars' guts out. And there's an artistic representation.
Eating a chicken whole and spitting out the bones? Is it like, what's happening?
More like you pulverized it into a dusty, gassy powder, and you are shooting it at about quarter the speed of the light into space, which I've done on a few Saturday nights. Yeah, there we go. All right. So basically, using radio and infrared telescopes, an international team of scientists led by Miguel Perez Torres of the Institute of Astrophysics of Andalusia in Spain, beautiful place, and Seppo Mattila of the University of Turku in Finland, I've always wanted to go, were able to capture unprecedented details on the evolution and formation of a jet emanating from a black hole as a result of stellar consumption.
Interesting.
Yeah. So these violent occurrences, which will henceforth be known as TDEs, or tidal disruption events, it's a little bit more of a classy name, I guess, happen when a star travels too close to a black hole's event horizon and is shredded apart by its massive tidal forces, resulting in a jet of stellar material ejecting into space. This hungry supermassive black hole in question weighs in at 20 million times the mass of our sun and is located in the middle. Okay. Yeah. So that's how scared I get when I talk about these things.
Clearly.
And is located in the core of a galaxy 150 million light years away in a merger galaxy pair, ARP-299. So these are two galaxies currently coming together as one, which is not as romantic as it sounds. Only a small number of TDEs have actually ever really been detected in the past, and usually we were able to see them because of their brightness in the visible wavelength versus infrared or radio. And according to Mattila, as time passed, the new objects stayed bright at infrared and radio wavelengths, but not in visible light and X-rays. The most likely explanation is that the thick interstellar gas and dust near the galaxy center absorbed the X-rays and visible light and re-radiated it as infrared, which is why we're able to see it in the images that we just showed. The team patiently studied this event over the span of a decade, and their patience more than paid off. It was initially observed in early 2005 as a bright flash of infrared radiation, and this was detected actually by the William Herschel telescope in the Canary Islands. Scientists actually initially thought it was a supernova. And radio telescopes all over the world have been tracking what they thought, again, was a supernova. But in 2011, scientists witnessed something amazing, the elongation of the radio source. And it proved that it is indeed not a supernova, but a jet with a speed that, like I said, clocks in at about quarter of the speed of light, or about 75 million miles per second. You know, just a nice, comfortable jogging pace. But I think that's so amazing, though, because, I mean, imagine you think you're imaging what is just a supernova, which is cool, but, we see those. But then to see that source turn into like this stringy spaghetti, I'm sure that's not what they called it. Must have been pretty epic. So TDEs like this one can give scientists a peek at the elusive environment that galaxies may have developed in the early universe. And by continuing to peer into the universe with infrared and radio telescopes, this could usher in the discovery of several more TDEs that were previously obscured by gas and dust. As Perez Torres explains, much of time, supermassive black holes are not actively devouring anything, so they're in a quiet state. Tidal disruption events can provide us with a unique opportunity to advance our understanding of the formation and evolution of the jets and the vicinities of these powerful objects.
Interesting. Done.
Whoa.
Boom.
Mic drop.
Mic drop.
That just happened.
That was dramatic. I'm sorry. I made myself uncomfortable.
There's a question in the chat room that I want to get to that you very well may not be able to answer, and that is totally okay as well.
I can answer all questions.
Sure. The question
whether it'll be correct.
Right. The question comes from the username. I'm curious how long a username, and it just sort of drops off, so I guess you got your answer there. But it says, is that stellar material full of more complex atoms than what went in? Like how a supernova's energy leads to more complex atoms. Do you think we can tell through I can't say that word.
Spectroscopy.
Thank you.
Sounds like a medical
It does.
thing. Well, that's a good question, though, because, in supernovae, or at least in events that cataclysmic, like the temperatures and the energies get so high that you do start to form those heavier elements. However, what ends up getting spewed in terms of radiation, now that's a good question. I'm not entirely sure what would actually compose that. I mean, Sarah, would you know?
I don't.
So it was a star that was, I mean, I guess it depends on the original star. The star was about 2 times the mass of our own sun, so it's probably comprised of a lot of the same elements, a lot of helium and hydrogen, some oxygen in there.
Yeah, and
We have someone that might know.
Oh, hey!
Love
How about that?
Yes!
Who might know? Oh, hey!
Dr. Charles, please
Enlighten us.
Enlighten us.
Save us.
Sure. If I understood the question correctly, I haven't heard it exactly, but the question is that when a tidal disruption event occurs, could new heavy elements be formed? Right?
Yeah, to a certain extent. Yeah, exactly. Go ahead.
Right. The answer to that question is maybe. We don't know the exact answer yet. The problem is this. You see, in the sun, when we cook hydrogen and helium and make a huge amount of energy, and in the process have the byproducts of new atoms that are formed, and nuclei, shall we say. That's a process known as nucleosynthesis. The temperature and the pressure are extremely high, and it has to last for a very long time in that environment for that to occur. Now, if you have a circumstance like this tidal disruption event, there's certainly enough heat, there's certainly enough pressure, but is there enough time for those elements to build any appreciable amount over a long period of time? So we don't know the answer to that question yet. We do know that there's a huge amount of processing that goes on. So one of the things that people have been looking for in the environments of supermassive black holes for tidal disruption events or other kinds of consumption events that we are looking to see whether or not new elements are being formed. That is still under investigation. So it's a great question, actually. It's one of the forefront questions of modern astrophysics.
Nice.
Beautiful.
Thank you so much.
Yeah,
My
that's-
goodness. That was so eloquent and just like, well, actually, I'm so glad you stepped in. So thank you so much. You saved us. Saved me.
That's beautiful. Oh, yeah, that was awesome. There is more from Dr. Charles, of course, a little bit later on.
That was just a teaser.
Exactly.
Just an
In case you're
appetizer.
interested. So, Miss Sarah, you're trash talking now. Like, what is happening right now?
Wow.
All right. Okay. Trash day in low Earth orbit. Finally.
Yes.
Oh, yes. Okay, so the space right above Earth's atmosphere is littered with junk. Dead satellites, spent rocket pieces, various other bits of space flotsam that just haven't had the decency to fall back to Earth yet. All right. This doesn't pose too much of a risk to us here on Earth, as most of the small bits that fall out of the sky burn up in Earth's atmosphere. But the problem is if you are sharing that orbit. So other satellites, other humans that are up there with that debris. Okay. Now, why is that so bad? Space junk, it's just junk, right? Little pieces of a rocket. How bad could that be?
That can't hurt me.
No. The problem is how fast it's going. So space debris is moving at orbital velocity, or 17,500 miles per hour. And at that speed, a 1-inch screw that weighs just 1.5 grams, or 1/300th of a pound, has the same energy as Terry Crews running at 65 miles per hour.
Into my arms, because we will get married one day.
Oh, yes.
Obviously. So the big deal here is that if you like when you're in a car, for instance, and you roll down the windows because it's a lovely summer day, and you've got your hand out the window, like everything
and you're
there,
flying it like you do.
Right, seems totally fine until you hit that tree branch.
Yes.
Right?
That rips your arm off.
Right. And so, but the general idea is that, or the sort of most logical thing here is like, well, yeah, but we're all traveling at the same speed, so that shouldn't hurt. It's more the perpendicularness of you and said item traveling at very, very high speeds.
Very, very high
That's
speeds.
what makes it the most dangerous. Is that correct? Okay, perfect. Just want to make sure I totally understand. All right. So then, how do we do this? What do we do about this?
All right. Well, that is where remove debris comes in. Okay, remove debris is a proof of concept satellite that will test 4 techniques for clearing that junk. It'll test what are called net capture for trapping and reeling in derelict satellites, vision-based navigation for on-orbit target acquisition, harpoon capture, which is as cool as it sounds,
No kidding.
and drag sail deorbiting.
Interesting.
All right, so they literally open a sail that catches the Earth's atmosphere, and that slows the piece of junk enough for it to fall down through the atmosphere and hopefully burn up.
That's really fascinating.
Okay, so one of the things that really piqued my interest on this one was the net capture, because to me, you throw a net out into space, that's just going to be a tangled mess.
Right.
Well, they were actually counting on that. So, around the edges of the net are what they call deployment masses, and those are supposed to carry the net around the target, and then once it reaches the other side, get tangled.
Oh, kind of
in
like
themselves.
like old Scooby-Doo cartoons, right?
Yeah.
You're trying to catch the bad guy,
Right.
and you got the net with like the rocks on the end of it,
Exactly.
right? And then you can throw it on, right? It's like that.
Exactly.
Okay, cool.
You capture the ghoul.
And then it works in space too.
That's awesome.
All right, and they also combine the masses with a cinch, a mechanical cinch that as the masses are tangling, it pulls the neck of the net closed.
Gotcha. All right, so
All right.
this is a real thing, yeah?
Yes, so Remove Debris was launched on April 2nd on a Falcon 9, and it was brought aboard the International Space Station for assembly. It did. Some
here.
assembly was required,
Yeah,
yep.
this picture. Okay, that's cool.
And on June 20th, it was deployed using the Caber Microstat deployer. Caber is a commercial deployment platform mounted on the ISS and owned by NanoRacks.
Love those guys.
Right? A Houston-based company. And Remove Debris is the largest satellite deployed from the ISS so far.
Nice. That's
Right.
really cool.
Yeah, so in the video, you may have noticed that the team are not testing this on real trash. Instead, the satellite is deploying CubeSats to use as test trash.
Nice.
That's because space law as it stands right now prohibits you from interfering with anyone else's property in space, even if it's trash.
Interesting. That's kind of too bad. So what if a lot of people, a lot of different organizations, even individually, if this works, right?
Yes.
So then that means that the European Space Agency, the Japanese Space Agency, Intelsat, I'm trying to think of other people who put satellites up in GLONASS, we'll go with that.
Yeah.
So if they all get together and they're like, hey, there's actually a janitorial service in space,
Yep.
they could all essentially individually hire
Yes.
or do this, right?
Yes.
Then that's really cool.
And that would be so cool too, to be a space trash man. You're operating remotely, but it's you still have the jumpsuit and you just go into work and it's time to clean up the.
It's time to
So
make the
anyone else
door.
seeing the intro sequence from Titan A?
Right. Well, so then, all right. What after they capture it? What happens then? Where does it all go?
All right. So once they've got the stuff captured and they either do the sail or whatever they can do to drop it into the atmosphere, okay, it's going to land hopefully in Point Nemo, which is it's in the South Pacific, and it is literally the farthest point on Earth from any land.
Interesting.
Point Nemo means point no one.
Right.
And so it's also known as the space graveyard, because if you still got control of your satellite when you deorbit it, you aim for this point. So much of
Gotcha.
the space debris that we have done deorbited intentionally is already there.
Oh, so that makes the Disney movie even funnier now.
Right?
I was like,
Found it.
right? Interesting. Oh, that's fascinating. All right, really cool.
Yeah.
Yeah. Any more questions? We're good.
No, considering, that was very, very well packaged.
Oh, thanks.
Nice.
So,
We were.
thanks for delivering that.
If you weren't watching
to
live,
the door of my mind.
Miss Jade was talking about how she was going to be doing that story, and Sarah's like, "Well, I'm
Yes.
glad you didn't, because I got
what
it."
would I
So
have done?
I know.
that's,
I was like,
that worked out perfectly.
glad
You would have fought. RPG stance.
All right, so what we're going to do now is we're going to take a little bit of a calendar break, and when we come back, Miss Athena will be on the observation deck with her interview with Mr. Dr. Charles. Stay with us. We'll be right back.
Into her face, determination in her eyes. She won't give up or quit or fall for little fashion lies. Filled on some expectation. This girl's a fascination, and nothing in her way will keep her from her destination. 'Cause she's fire walking, she's fire walking. When it's hot, she keeps on moving. The heat keeps on improving. Yeah, she's fire walking, she's fire walking to be free.
Hello. I wanted to make sure we give another thank you to our Escape Velocity citizens, of course, and I also wanted to acknowledge our Orbital citizens. These are the citizens who contribute $5 or more per episode. And again, if you would like to become a citizen of tomorrow, head on over to patreon.com/TMRO. And now here is Athena with Dr. Charles Liu.
Hey guys, awesome. So thank you so much, Charles, for coming on today. I'm really, really stoked to talk about some of your research that you've been doing lately. So, observational galaxy evolution. Tell me a little bit about why you chose to go down that path for research.
Well, that's a great question. It is sort of a joke that every young person, when they first start doing astronomy, they want to do cosmology. They want to study the theoretical underpinnings of the entire universe. And I was no exception. When I first started as a college student, it's like, hey, I think I want to do theoretical cosmology. But then the theoretical became observational, which meant that I was actually looking at stuff with telescopes and tools like that instead of just staring at a computer screen. And instead of doing cosmology, the entire universe, I wound up doing galaxies, which is close. It's still pretty big. They have hundreds of billions of stars in them, lots and lots of planets, gas, dark matter, things like that. They're the constituents to the universe that, say, atoms and molecules are to something big, or say even cells are to the human body. So as for evolution, in astronomy, evolution doesn't mean, say, natural selection, where you have two different species that are battling out, and whichever one wins is the one that survives. But the idea that things change over time, slowly, right? So evolution is just the passage of time in the overall history of the universe. So I became very interested in that as time went on, and in graduate school that became my primary focus in my career, which I still do today. And I'm happy to talk about the details of it because there's lots and lots and lots of cool stuff, including some of that black hole things that the previous news broadcast was covering. There's some really neat things to talk about.
Yeah, there's so many awesome things. So what did you end up researching over the past year then that has been some of the most fascinating that you've gathered in the data you've been analyzing?
That's a great question. The past year or so, I have been doing some work that's been funded by the National Science Foundation and by the Alfred P. Sloan Foundation, working on galaxies that recently collided. And by recent, I mean within the past billion years or 2 billion years. And what happens when galaxies collide is that usually their gas swirls into the center, right? And then that swirling process fuels the supermassive black holes at the center and creates also, aside from this, what we call active galaxy in the center, the AGN, we call it, active galactic nucleus, it also triggers a whole bunch of new stars forming. So you create a whole new generation of stars that now litter through this galaxy that has collided and merged. And so after that post-starburst period, what happens to the galaxies, right? Almost every galaxy in the universe, sooner or later, will undergo a collision that creates a starburst. And so what happens to it thereafter is the history of pretty much every galaxy, including our own, the Milky Way, eventually over time. I find that very interesting because we want to know, after the most violent things occur, what is the steady state? How do we return back to this calmer life? Say, you're changed, you're different, but it's a longer term thing that eventually results in the ability to form things like planets and evolve life and things like that. So that's the kind of thing I've been doing. I've worked with a lot of students on this, and it's been a real pleasure to do it. I really find it fascinating to find galaxies that underwent cataclysm recently in the history of the universe, and that maybe galaxies that will soon undergo these kinds of things. The Milky Way galaxy, our own galaxy, and Andromeda, which is our nearest large neighbor, about 2.5 million light years away, are on a collision course. Their mutual gravitational interaction will cause them to crash into one another sometime between 3 and 5 billion years from now. Now, odds are we will not be on Earth the same way that we were before, but in any case, it will be interesting to know that I think I am working on, studying, trying to find out what will the Milky Way, our galaxy, look like after that collision, and what are the odds of things like new stars forming, life forming, what the shape of our galaxy will look like, what the contents will be like. It's a lot of fun.
That's so cool. You pretty much answered one of my next questions, which was why, it's important to you to really be studying these, because you mentioned, eventually life, other planets forming, other planetary systems. But if there was one main reason as to the importance of you doing this research, what would that be?
Well, That's a really great question. And a lot of my students ask me these questions, especially students that aren't planning to become scientists. Like, what is the value of astronomy and space studies and things like that? Why does it matter? And my answer is a little philosophical, but I think it's absolutely relevant and true in our modern times. The answer is that astronomy and studying these things, these galaxies that are, say, huge, much bigger than our world, and they're the processes that will take far longer than human lifetimes, that kind of basic curiosity-driven examination of our universe will not change the price of bread today, but it could change the course of civilization tomorrow. Yeah. Everything that we do now is basically laying a groundwork for the things that will happen in the future. All the issues of our world, the environmental challenges, or say our technological challenges in the future, whether we'll be able to go beyond low Earth orbit, whether we'll be able to populate low Earth orbit or use it in a way that will help our lives here on Earth and eventually take us out into the world, into the universe. I think that those kinds of questions have to start with the initial curiosity-driven questions, the things that we're trying to investigate, things like GPS, things like the general theory of relativity, those things that affect our daily lives, our cell phone communications, our cameras, our ability to monitor data, computing power, internet. All these things came originally from wondering and investigating things that we don't really understand just yet. And then there's a second point. I'm sorry, Athena, can I go on and like give a second reason why I think this is most important?
Yeah, please do. This is amazing.
Okay. The idea is this, right? We human beings, when we're born, we know our cribs, right? Then we know our bedrooms. We might know a small part of our homes. And then eventually we might get to know a larger part. Then we start stepping out into our neighborhoods, into the block. And then maybe someday we know our school. Then we know our towns and our cities, our countries. We're growing as we age and understand our environment and then interact with it a little bit better, right? In a more sophisticated and more mature kind of way. Astronomy is kind of like that, but not just for us as individuals. It's for the entire human community, right? We're just taking our first baby steps off our own world out into low Earth orbit or to the moon for brief periods of time. Now we're sending spacecraft missions to Mars, to all the other planets, to Pluto, beyond our solar system, hopefully someday, slowly but surely. Yeah. All these things are our ability to move forward out into the universe and become citizens of the entire universe. We live here, and by not keeping ourselves just tied to daily survival, thinking about larger things, we understand that, it can be the crappiest day in the world, but overall it's okay. Everything's going to be fine. As long as we keep looking and growing. I think astronomy, the kinds of research that I do, whether or not I affect tomorrow's stock prices or anything like that, I know that I'm looking at something that is going to be a valuable thing for us all. And I'm really lucky that I can actually make a living doing it and share it with people that I get to hang out with, students and people like all of us who are listening today. So I thank you all. I appreciate it.
Of course. That was such a great answer, Charles. And every time I talk with you, I always feel so enlightened because you really have this way of connecting the universe to humanity and us here on Earth. And I think that's just absolutely amazing. There is a question from the chat that I do want to ask. It comes from Loopy, and they ask, how do we actually know for sure the shape of our galaxy? We haven't exactly sent something far enough to take the selfie that makes Voyager jealous. I'm wondering what you have to say back to that.
That is a superb question. And it's an age-old question, right? Think about the ancient Greeks. How did they know what the shape of the Earth was, right? They're small. They only have very limited range that they can go elsewhere. And they had to make approximations, or they had to make estimates or extrapolations. We have to do the same thing today with our Milky Way galaxy. And it kind of goes something like this. If you are, say, a fish in the ocean, and you're not able to actually go all the way to the edges of the ocean, if you had technology, then you might be able to send a little sonar burst right? Maybe a targeted shot out in each direction. And then if you get a bounce back, eventually you'll be able to make the outline of the ocean shore wherever you are, and eventually make a map of the ocean where you live. We kind of have to do that, but we are lucky that things out in the universe emit light. So we don't have to send out a pulse that then comes back to us. Instead, we can just use our telescopes and look at what comes out. We take a census of the sky. And then in every direction we look, we see where the stars are and how many of them there are, what kinds they are. And then we see areas where there are no stars, areas where there are lots of them, where the light is. And over time, we're able to map using the starlight mostly, but also the light from other things, nebulae, and even nearby galaxies, that will help us map out the overall light profile. And then we can measure the motions of both the stars inside our galaxy and also the objects outside our galaxy, like clusters of stars, globular clusters, even our satellite galaxies near us, the Magellanic Clouds, for example, the Sagittarius dwarf. All these different things together, we can then understand how they move, and thus from there know approximately how far away they are, the kinds of shapes of the structures that they belong in, and putting them all together, all that information together, allows us to get that sense that we live essentially in a very thin disk of stars, and we're kind of at the edge. So if you imagine a pizza that's a tenth of an inch thick, then we have this big pizza here, and we're kind of near where the last pepperoni is before you head out to the nice thick crust on the outside. That's kind of how we do things. And we continue to study. We don't know a lot of things. It was only, say, within the past couple of decades that we realized that the stars in our galaxy near the center don't just form a blob, like a bulge, but actually form a bar. And this bar is really, I'm blocking myself. Don't worry, it's not important. It doesn't matter what I look like. It's what the bar of the galaxy is. So you have the bar here, which is kind of short. But what it does is the spiral arms come off the edge of the bar as opposed to coming right out of the central bulge. So these things are being learned all the time. Some of your listeners, some of the audience may have heard about something called Gaia, second data release, just within the past month or so. The European Space Agency and its collaborators, all the people who worked on the Gaia mission, have now released a map of 1.7 billion stars with a B in our galaxy. So the ability to understand the structure and the shape of this part of our universe, this part of our galaxy, has grown by leaps and bounds. Of course, there are hundreds of billions of stars in our galaxy, so we still have a long way to go.
That's so cool. Now, so I think that that's a really good answer. You obviously were saying as far as being able to visually see the light that's already being emitted, from the universe, from these stars. But what are the things we can't see? There's a question here from Henny's Vorwerp off of Twitch, and they ask, do you always see dark matter separate from normal matter in such collisions, referring to the galaxy collisions?
Great question. By the way, that username, Hanni Voorwerp, those of you who know, that was a citizen scientist named Hanni van Arkel from the Netherlands, who through the Galaxy Zoo project was able to discover a new kind of object that others had not yet seen before, and it's known as Hanni's Voorwerp. So cool name. Good call. The issue of dark matter and luminous matter moving differently has been a topic of great research over the past several years. In the past few decades, when we've confirmed that there is a lot of material in the universe that is there but doesn't emit any light, and electromagnetic radiation of any kind, as far as we can tell, that material has, for the most part, been connected to the luminous matters, the atoms, the molecules, the protons, neutrons, electrons, neutrinos, things like that. Now, what we are understanding is that sometimes those things can decouple just a little tiny bit. Most of the time, though, they're all still quite attached. There's a very well-known study where you have the dark matter and the luminous matter separating as two clusters of galaxies are coming together. We're not just talking about two galaxies colliding, but each cluster has hundreds, maybe thousands of galaxies, and they're surrounded by huge halos of dark matter. And this dark matter is not emitting any light, but it's acting completely gravitationally like all the rest of the material. So as the dark matter is coming through, and they're combining these two clusters, becoming one. Again, I'm blocking my face. I'm sorry. That's okay. As we do that, the gas that's not coalesced into stars necessarily, they're coming through. But because the gas interacts with one another, they have this sort of the friction interaction between them, they're coming together at a different rate than the dark matter coming together. So that's one way to confirm the existence of dark matter, to make sure that, yes, the material that is bound by gravity is moving differently from the material that might be affected by things other than gravity in a significant way. So most of the time, the dark matter and the luminous matter move together. But a lot of the time, because there's so much more dark matter than luminous matter, you see motions even when you don't see stars. And that is a kind of decoupling. But this kind of dramatic decoupling between, say, dissipative effects, non-gravitational effects on luminous matter, which we can see compared to the dark matter that we can detect using the gravitational, say, signatures of this motion, is getting very interesting. I think is really cool. The specific term for dark matter and luminous matter moving separately from one another, one term is called velocity bias. And there's been a bunch of papers published about that over the decades. I don't know where the status of that research is yet at this moment, but it's kind of cool.
Velocity bias. Okay, that's pretty cool. I like that. I'll be researching that later. So I understand that sometimes in some of your free time, you like to research quasars. And is it that you hunt for quasars? Tell me a little bit about that and why you do that.
Okay. Do you remember the television brand Quasar?
The television brand?
Yes.
No,
there was a company called Quasar. I think it was based in Wisconsin that made televisions.
Okay.
And
some people
the
remember,
commercial would
yes.
come on. Quasar. Wah, 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 wah. It is very cool. But yes, a quasar is a quasi-stellar radio source. And it's actually, as a term, it's relatively new. The idea was that you find these things because they are supermassive black holes that sit in the centers of massive galaxies. And when matter falls into them, the matter that comes close but doesn't fall all the way in can achieve enormous energies, and as a result will release all kinds of radiation, physical jets, and just be a massively influential thing in the evolution of that galaxy. So I was interested in quasars originally as a way to understand the galaxies inside them. But there's another way to use quasars as well, because they're really bright. Okay, part of the reason they became known as quasi-stellar radio sources is because they were like stars, even though it was realized that they are millions and billions of light years away from the Earth. They looked like stars that were only a few light years away. Why were they so small and compact? Right? And it turns out that because they're at the centers of galaxies and they're powered by supermassive black holes, which are small, even the most massive supermassive black holes are only slightly larger than our solar system. And as a result, you look at them and you could swear that they look like stars, and yet they are producing tremendous amounts of radio energy and X-ray energy and even visible light, which you would only expect from tremendously powerful sources. And so the concept of the quasar as a beacon in the universe is a fascinating one too. If you can find a black hole that is undergoing a quasar stage of activity, and it happens to be, say, billions of light years away, as it shines toward us, it will pass through clouds of gas which otherwise would be invisible to us because they don't emit enough light on their own. They aren't conducting nuclear fusion, for example. Not enough starlight is coming through. But just as you can shine, say, a flashlight beam through a cloud of chalk dust and you can see the dust being lit up, right? By the same token, if you shine through, you can see the effects of the quasar's light on the quasar light by all of this dust, right? The dust or the gas will have atomic interactions with them or scattering interactions with this light. And as a result, you can actually study the non-luminous but not dark matter component of the universe.
Whoa.
Okay, as it turns out, yeah, it's really cool. And it's what's allowed us to realize that for all of the wonderful energy that comes and the amount of matter that is in galaxies, mostly powered by starlight or supermassive black holes and so forth, there's about as much mass that's just sitting out there in intergalactic space in clouds, vast clouds, as large or even larger than galaxies. They're just kind of sitting there, waiting perhaps someday to get to a point where they will form stars and new galaxies and perhaps new planets, new people, new plants, cool things like that.
That's so cool.
Hunting for quasars is a fun thing to do for that reason, because you find a nice grid of quasars all around, and then you can use them literally as searchlights to look for the hidden matter in the universe.
That's so awesome. So Destructor 1701 in the chat says, realized just after that Star Trek episode centered around a visit to a quasar. So because I read this in the chat, I want to actually bring up, you're quite savvy with pop culture, Charles. I definitely noticed. So I really want to get into, it's really cool. So I wanted to ask you how important you think it is for like science fiction, films, movies, novels, even like pop culture, like shows today and music, how important of a role that plays for prospective scientists or possibly students that don't know their path just yet.
Oh, it is the best. I am not really a pop culture expert, Athena. You know that. You know me real well. In fact, I should tell that. Okay, if I have a few moments, all y'all, I want to share with you how cool Athena is and was as a research scientist. You should know this. We'll get into that a little bit before. But Athena is an astrophysicist too. As a student, she did astrophysics research, and she was one of my best students. I'll tell you all about that if I get a chance. Okay, Athena? I know you're the host and I'm the guest, but I want to have a chance to tell people about that. But to answer your question real quick, okay. Pop culture is something that I like. It's not something that I research so that I can be, cool in communicating science and everything. And that's always been true for me. And so for that reason alone, I think that we all should love the pop culture, the science fiction, the songs, the music, the art, just anything that has to do with the inspiration of what the universe can provide for us is a great thing. And I think that we are all better scientists for it if we understand its impact on the public. There's a really unfortunate stereotype that it's a bias that even we scientists fall into a lot, where scientists are supposed to be staid, they're supposed to be antisocial, we're supposed to be wearing our white lab coats on distant mountaintops in the middle of nowhere, and we talk to no one, and we have really bad haircuts, and then we just sort of stare out in the universe or stare at our computer screen and make like massive discoveries that change the universe. That's not really how science goes about and how it should go about. Yes, it's true that there are wonderful examples of that in the overall world. And it's also probably true that if you want to study anything, the scientific or otherwise, that's scholarly or academic or sophisticated, deep, sometimes you are working by yourself, alone, thinking deep thoughts and not interacting and socializing at that very moment, right? But overall, if we don't have these other things that make us who we are, it also will detract from our abilities or our interests as scientists. Albert Einstein, who, as we heard earlier, is really a genius after all, right, wrote in 1930 in an article that was published in the New York Times that he said the origin of all art and science, all the greatest creative endeavors of humans come from that same impulse where we are like amazed by the mysteries that surround us. Whether those mysteries include artistic things or scientific things or philosophical human relations, all of it matters. And from that same wellspring of inspiration, we can lead to many, many different things. And there's nothing written down anywhere that's reputable that says that you can't do lots of different things at once. Mm-hmm. So, for example, you, Athena, as well as being a great scientist, have moved on to doing this other stuff, but your ability to be a communicator of science is greatly enriched. A communicator of any kind, really. It's not just science, right, Athena? All of it, because you have this extra depth of experience that you are exploring the sense of the mysterious, looking at things and going, wow, what the heck is that? How the heck does that work? What does that mean about us? So I'm 100% in favor of that, and you knew that, right?
Yeah, I mean, honestly, a lot of my growth and inspiration really came from you being my mentor. So I wanted to ask you what you think of the value of mentorship when it comes to students, whether in high school or once they get to college level, as opposed to just having, a student go to school and be in a classroom and do, exams and homework. What the value really is in having a mentor to pursue their careers, specifically for science.
Oh, it's so important. I think this is tough, and I might get in trouble with some of my fellow professors about this kind of thing, but education originated, really, university education, but all kinds of education really originated with the idea that you had to convey information to people, right? We don't have to do that anymore. There are so many ways to get information in our modern 21st century society that just the transfer of information from one person to the next is not nearly as crucial as it was, say, centuries ago in our society. What instead needs to happen is for people to understand what it's like to do what you do, right? So what is it like? What are you thinking about? What are the things that inspire you or humble you or motivate you to do the kinds of things that you care about and are interested in? And that's the kind of thing that I think is my most important task. I mean, I'm just one guy. I can make massive discoveries if I'm very fortunate and I work very hard. But in the end, my contribution is tiny. It's just one little bit in the entire amount of what still needs to be learned. So if I can help other people do stuff and become better than me, I want all my students to be better than me in every single way. I want them to be taller. I want them to be smarter. I want them to make more discoveries. I want them to make more money. I want them to, win more awards. Because what I can do is to help those folks who are rich with talent to get that motivation and an understanding of what they want to do. Right? Okay, so now it's time, by the way, Athena. I now have to take over and tell people about you.
What?
Is that okay?
No.
Why? Get used to it. Okay, so as you'll know from my bio on this thing, I teach at the College of Staten Island, in addition to my work at the American Museum of Natural History and the Hayden Planetarium. And Athena was a student in one of my introductory astronomy classes, right? Well, you remember AST 102 in that weird classroom 4N218 at the College of Staten Island, right, Athena?
Yes.
Yes, indeed. Now, Athena is not at that time, was not majoring in any science. But astronomy 102 was a general education requirement, right? And you and a lot of other students were taking this class to fulfill an education requirement. And all I did was to show you all how cool the universe is and how we study it a little bit, right? I tell people, look, you love math. You love physics. You have no idea that you do. What you don't love is math class or math tests or math homework or math teachers, right? It's that stuff. So the material you love and you are good at, and it's just other people or maybe whatever environment you've been in have convinced you that you're not good, right? That you're not able to, or this is not for you. So that's all I tried to communicate in my classes. And Athena, as it turns out, everybody, was one of my very best students that year. I think you scored a perfect score on your final exam, or maybe you missed one question, I think it was. I think, yeah, of all the students in there, I think there were 2 students that maybe 3, that either scored perfect on the final or missed one point. And I think you were definitely one of those 3. I don't remember if you were the one that got the perfect score. But anyway, Athena turns out to be really liking this stuff and asked a lot of great questions. And I just sort of said, you know what? Hey, Athena, you want to do some of this? Give it a try. See if you're interested in studying astrophysics and actually doing research. And you said yes, right, Athena? You tell us a little bit about your own personal experience with astronomy, because what happened was that you ended up joining our research work at the Museum of Natural History. And for was it a full year? Did some amazing stuff researching stars and the evolution of brown dwarfs, things like that. Hey, what did you do? Remind me, please.
Right. So
Remind us all.
Yeah, so there was an incredible CUNY program, City University of New York, that really had mentors that would mentor their students, which is incredible that obviously we got to be part of that. And I went to the American Museum of Natural History and were able to conduct research under NASA space grants and the National Science Foundation. So there was a lot of incredible students that were there and were able to conduct research in whichever field they really wanted to, or whichever. There was also biology there, and there was a few other subjects too, not just astrophysics, which was really incredible. And it obviously, of course, really moved me, and I know it moved a lot of students also to pursue the careers that they really wanted to in science. So it definitely was an overall incredible, few summers actually of doing that research. So again, thank you so much for that. But now we're to get towards the end of our interview.
No, do we have to stop talking?
Well,
I still have so many stories
questions
to tell about you, Athena. You know?
I do have a question though, because speaking of students and mentorship, I do want to ask you, what would be, if you had to choose like one of the most meaningful pieces of advice to give students that are wanting to pursue a career in researching, like to study the stars or the cosmos? What would be that one piece if they're on the bridge right now trying to decide whether to do it or not?
Oh, I don't know. For every person is different, right, Athena?
Yes.
I mean, for you, right? I don't know. I can't remember all the things that I told you and that you were very patiently listening to me, whether or not I was spouting nonsense or anything like that. Is there a single piece of advice? I think that realizing that there are a lot of people that are going to tell you what you can and cannot do in life, and that you just have to decide that, you know what, you're wrong. I can do literally anything. And eventually, if I do something for a period of time and realize that I want to do something else instead for a period of time, or if I want to change my focus or do something else, take what experience I have and run with it in a different direction, you just go ahead and do it. And you cannot be afraid of other people, even though the temptation is great to say, you can't do this, you can't do that. The most frustrating thing I see is when students are convinced by others that whatever they're doing is not valuable, or whatever their skills are, it's not enough. And I counsel everybody, say, look, you come here, you do things. And as you know, Athena, there are plenty of my students over time, research students and other classroom students, who wind up not being scientists.
Right.
But that's okay. In fact, that's great, right? How many scientists do we need anyway, right? We need people who communicate. We need people who talk. We need people who govern. We need people who do other things in addition to the research as well. But if you have that experience, you say, I'm not afraid. I'm going to do this for a period of time. And whatever I get out of it, I will have made a contribution and it will have enriched me. And you just go ahead and do that. And I think that's the right answer. There will always be opportunities to turn and do other things and new things. And at the same time, there will always be obstacles, right? There will be naysayers. There will be challenges that you have to face. And then you ask yourself, okay, how do I overcome this challenge? And sometimes you ask for help. Sometimes you talk to people. Sometimes you try to look at things a different way, and you move on and do other things in your life for short periods or for long periods, and you may loop back or you may not. It doesn't matter. The important thing is to realize that you are good at that stuff, right? If you are, I don't know how many times I've received comments from people saying, oh, well, I'm no good at physics, or I'm no good at math, right? And I'm no good at computers. To which I say, no, that is not correct, that you're not any good at it. The answer is that you're not good at it yet. That you can be if you want to be. You can choose not to be, or you can choose to be. And it may take time. It may take effort. You may have to overcome obstacles. But it's not that you can't do it. It's not that you aren't able to, no matter what anybody tells you. That's not true, right? Instead, what you are is not good at it yet. And so find people who will help you with that, and do it yourself and keep pushing forward. Design your own future. it's kind of inspirational in a sense that it has nothing to do with astronomy in specific. But you know what I mean, Athena? I mean, you know what I mean better perhaps than anybody else. I mean, as an awesome student in so many things, and including science and contributing in scientific research, and then moving on to doing other cool things that you're doing today, is really cool. And it's an example of the best kind of thing that can happen from an education. And I'll mention one more thing, okay, Athena, because I want to tell people this. A couple of years ago, I was teaching a seminar for budding scientists, for people who wanted to be scientists. And Athena very kindly came to the class. We had a special sort of hour with her where she talked about her career path and the kinds of things that she did, both scientifically and otherwise. And at the end of it, the students are all so moved. They all so appreciated you. You know that, right? And there was one student I remember that came to you and she was like, "Oh, can I give you a hug? What you're saying and who you are is so what I needed to know right now, so what I needed to hear, the kinds of things that matter so much to me." So that's the kind of thing that you can do too. That's what anybody can do as a result of their education. And that student, by the way, Athena, just graduated from college, and she's now going on to get a PhD in astrophysics at Harvard. And
that makes me so happy to hear.
You rock. Very simply. And all of you, all of you who are doing this podcast, all of you who are doing this kind of work, you're making the difference. And that's what it is. By convincing people that you can do it if you want to. You don't have to do it if you don't want to. But in the end, it's only a matter of what you haven't done yet.
Yeah, exactly. Well, that's incredible, and that's great to hear. Obviously, that she went on and pursued her to get her PhD, and I think that obviously that's what a lot of us really agree with on this show, and the citizens of tomorrow that are watching right now, like. We all understand, the umbrella of space and of space exploration and how empowering it is to each of us. And so I love that everyone's able to make those connections with each other, whether it's, you're at a coffee shop and you're talking about space or, obviously a seminar, wherever it is. So that's incredible. Thank you for sharing that story. I love that. So, there's a few questions we love asking. There's no wrong answers, but they're super open-ended. So the first one is, what is your favorite space mission, past, present, or future?
Oh, geez. My personal favorite has to be STS-6, the first launch of Challenger, the space shuttle.
Wow.
That's because I have a personal experience with it. Yes, this was 1982. Right. Columbia had already gone up 5 times, if I recall correctly. And remember, all my facts and figures may be messed up depending on how bad my memory is right now of that event. But the 6th launch was going to be Challenger, the first launch of a second space shuttle. And my family, just at that time, as it turns out, was going on a family vacation. We're driving down all the way to Florida to see friends and then eventually see Disney World and Epcot Center, which was pretty new at that time. And the day we arrived into Florida itself, they were like, "Well, we have like half a day. What should we do?" And I bugged and pestered and I begged my family to take the, that was a 1977 Dodge Aspen, I think we all drove in, to Cape Canaveral to watch the shuttle launch. And my family was like, "Oh, come on. We can't get close. We're going to be far away. You can't see a thing. No one's going to be there. It's going to be boring. It's going to be whatever." And I was like, "No, you got to go. Please, 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 please." And to this day, I'm grateful both to my parents and to my little brother and my older sister who put up with me and agreed that we would go over to Cape Canaveral and go see this thing. I remember we finally managed to find some parking because, of course, all the shorelines were all crowded across like a body of water. I don't even know which one from the launch pad, but we were there with a whole bunch of other people. I remember having conversations with them. There were people in campers, people in cars just like us, and kind of sitting around the side in picnic chairs and just sort of watching. And of course, there's no live feed at that time, no internet. People were listening to the radio to make sure that it was still going on. And there's the launch things going, and old-fashioned, all stuff we see on YouTube from the old launches. And of course, the launch tower itself was this big, way, way far away. We could only see it by binoculars. And fortunately, some people with nice binoculars, lent them to us, and we could take a look and wow, there it is on the launch pad and everything. And then we were able to hear the countdown and over the radio. And then the launch happened, and it was going up. And again, little tiny thing, right? Like a match, it looked like from where we are. But we all were very, very excited. We didn't hear the sound. I don't even remember to this day if I heard the sound of it at all, because we were so far away. It may have heard a low rumble many seconds later. But it was going up, and I was there with my Kodak Instamatic camera, the 110, like taking pictures, going up. And I was like, whoa, this is so cool. And that probably, if I think about the overall launching and stuff, that was my favorite one, because that was the one that I was closest to as a human being. And I was a kid, and I will always remember it.
Wow, that's such an awesome story, man. That must have been so cool to see, even though it was super tiny, but I'm sure it was moving. So the next question would be human or robotic exploration of the cosmos?
For now, robotic, eventually human. It is inevitable that we human beings go out there. Right now, there's still a lot of things that we haven't quite figured out yet. Going as a human being right now is probably too risky. We don't want to, go. I know there are plenty of people who are willing to go even if they have a large percentage chance of not surviving. But really what we should do is to make sure that we can be as safe as we possibly can. In the meantime, though, our robotic explorations are superb. They are excellent. They are extensions of ourselves out into space. Our eyes on Mars, for example, through Curiosity rover, or say our view of Saturn's rings through Cassini as it was plunging through in its final grand entrance, grand exit, whatever we called that, grand finale. That is really beautiful for now, and I'm quite satisfied up to this point. And then when the time comes, we should go out there and take a look ourselves.
Yes, I definitely agree with that. Awesome. So where should we go next?
We as in we humans, or we as in using our spacecraft?
Both.
Okay. We humans should next go to Mars.
Okay.
I think we can go back to the moon if we want to, but there really is no need. Going to Mars is the next step. I think it'll happen within my lifetime, that there will be about as constant a presence of humans on Mars as there was a presence of humans on the moon. They were there. They stayed for a period of time. They picked up rocks and so on. But I think Mars is a different situation than the moon because it takes so long to get there and so long to get back, right? Difference between a few days and the better part of a year, just a one-way trip. There's a huge difference. So when we go, we want to do it right. We want to get there. We want to be able to come back on a regular basis. We want to be able to survive there for a long period of time if we need to. And so it's a thing that will happen. I'm very confident it'll happen in my lifetime. I'll be very happy to see it. And so let's do that for sure. Okay.
Yes.
And all the young folks out there, we're counting on you. Sorry. We old folks, I don't know if we have the vision and the ingenuity and the stick-to-itiveness to do it. I hope we do, but if we don't, it's up to you all young people. So please do it. And,
Yes.
and by young, I mean anybody under the age of like me, okay, which is there are a lot of you. So and I appreciate that, all of you who do that. In the longer distance category, like non-humans, where we need to go is, this excludes places we've already gone, right? Or already planning to go, like spacecraft that are already set up. For example, there's a great spacecraft mission that's being designed to go to Europa, right? To go to the icy moons of Jupiter, to really land there or to figure out what the situation is as far as extraterrestrial life goes in those areas. So that's something that I probably don't want necessarily to duplicate and to say, well, we have to go there for sure, because we're already planning that. So everywhere in the solar system is a place that we should go. Eventually, it'd be nice to go even further beyond that. I would really love to see more information about the heliopause, this bubble of ionized gas that sort of marks the boundary of our solar system beyond the solid objects like the dwarf planets and the Kuiper Belt objects and things like that. There's just so much to do, and I look forward to being part of all that. It's a lot of fun to think about.
Yeah, definitely. Awesome. So for the very last question is why space?
Why space?
Yes.
Why space? Because it's there. Because it represents everything that we can do that we haven't done yet, whether or not we know what we're getting into, when we look up, when we look into space, when we think about space itself and the universe as a whole, it makes us something more than just organisms attached to a planet wondering where our next meal is coming from. It elevates us to the level that I like to think that we humans are capable of. And space represents that aspiration, which I think we all should be thinking about for our future, our legacy on the existence of all of us, both individually and collectively. That's why space.
Wow, well, that is an incredible answer. I couldn't have said it any better. Well, Charles, thank you so much for coming on the show.
Thank you, Athena.
This was such a good conversation.
Again, let me just say, I am so proud to have been one of your professors. And what you have done and what your colleagues and friends are doing is so valuable to us all, not just me as an astronomer, an astronomy professor, astrophysicist, whatever, but like all of us. And so keep on keeping on. Thank you. And I can't wait to see what you're doing next.
Thank you so much, Charles. Okay, so we're going to do a quick break. And when we come back, we're going to look at your comments and questions from last week's show. Okay, bye, guys.
Science. It both draws us together and tears us apart, brings discoveries to cure us and threaten us. It is neither good nor evil. It is what we decide to make of it. There is so much more to learn, and we are curious. Together, let's explore the science of tomorrow.
Right, there's
we're
four of
short
us.
one.
Yeah. Oh, God, I didn't think this was so heavy.
Yeah, it's really heavy, sorry.
Oh, my gosh.
I'm the short one.
Okay.
You totally glitterized this entire chair.
I don't know where that came from.
That is amazing.
The couch
grab
is
this.
sparkly.
Oh, jeez. I should have Jade do this. Okay. All right. So high.
Yeah, I know. That's why I was like, maybe I should
Maybe
be
I
on there.
should. Do you want to switch?
Sure.
Unless we have to do cameras,
sorry.
I'm not sure. That's okay.
How do we frame that?
Suppose we should
this is so
flip
nice and
computers too,
small.
huh?
What is that, an error?
Yeah.
What? I like that. Okay. Yay.
I looked down and I was like, why is there glitter all Oh, it's her shorts.
There's some on the couch too. I'm sorry, guys.
Down a little bit.
No.
Okay.
And I'm the short one.
Okay, that's fine.
It's between Sarah and I, neither one of us have a torso, so it's going to be one of us. We determined that earlier today.
Oh my gosh, that was such a good news, guys. That was such a good news segment.
It was.
That
Thank
was
you to
so good.
Charles. I keep calling him Mr. Dr. Charles because I
That
spelled
was chat
initially,
initially, doctor.
and I feel really terrible.
I love it. It was great. Did someone make a GIF? Am I always say that weird? I'm sorry. I'm just going to start saying if. Of you, right?
It's a GIF.
Wow.
It is GIF.
There you go.
Indeed,
No, but
but
he's
It's
being
Geif,
dumb.
actually.
but if you like Google it, and oh gosh, I'm gonna stop.
It's Jif like
I've
peanut
had
butter,
this
even though it's
conversation.
spelled
I know,
wrong.
yeah, right.
That's really
That's
what it
what
comes
it
down to. All right.
Yeah, because the owners say GIF.
Just before comments, I want to make sure I give another thank you to our escape velocity citizens. I also want to give a huge thank you to our orbital citizens, and then, of course, our suborbital citizens. And these are the people who contribute $2.50 per episode, and every little bit helps. If you would like to be able to contribute to the show and, you know, kind of feel like you're in on all of the awesomeness that you see here today, feel free to head on over to patreon.com/TMRO. trying to give everybody enough time because Ben is adjusting all of the cameras as we are here live in the studio. So last week we had a really great, really great. If you missed that one, please go back and watch it. Just like I will say the same thing next week about this week on 11.24, Miss Kim Stedman on the different personalities of the JPL rovers. We did cover a lot more ground than that, of course. But that was kind of one of the sort of more defining moments, I think, of that particular interview, which is really great because it's one of those things where, it was funny. Mr. Dr. Charles just talked about how one of his favorite missions was the Challenger mission, the first Challenger mission, and I thought, STS-6, like that's like super random to just kind of pick out of the air. Like I don't even remember STS-6, and then that story was really fascinating. And I think after a while, after talking to a lot of different, I don't mean this badly, but shuttle huggers, each orbiter kind of has a little bit of a different personality. So it was interesting to talk about the rovers also kind of having a little bit of a different personality there as well. So that was really cool.
Yeah, I love that. The interview from last week. It was so good.
That was awesome. All right, so questions and comments about last week's show. Well, first one comes off of Reddit, actually, from Froggamezog. Great. Thank you, ladies, for helping me out with that one. Says, this is interesting, but honestly, I found the next piece on space station concepts to be even more interesting. I think space tourism offers a very real possibility for growth in the launch market over the next 10 years or so. Now that the Falcon 9 is approaching full maturity with Block 5 and the first Falcon Heavy has flown, it is much more realistic for designers to plan commercial stations specifically for tourism, which is that's fascinating. Right? Like if you were going to be on a tourism station, like what are you expecting to see?
Oh my gosh, I would just want everything.
Yeah?
I want everything there. But I like the point that this person brings up about obviously the Falcon 9 Block 5 with obviously the new configuration. It's going to be able to launch and land multiple times without having to really be worked on. That's the goal. Too much, which is exactly what we need in order to have space tourism for transportation. So I'm like, yes. But yeah, I would probably be one of the first people if we could go for tourism to go.
Yeah?
Definitely, yeah.
Nice.
I mean, it'll probably cost a lot.
You think you need a passport?
I was wondering that a couple times ago.
Passport.
Yeah, you know how cool that would look? It would say Earth.
There it is again. Basically twinsies. It's appropriate we're sitting on near sides of the table.
To make sure you two are separated.
We might fuse into one.
That's awesome. Would you go?
Yes.
Yeah?
That's a question? Of course.
I think it is a question.
I know, it really is, but it's such a reflex for me. Of course, you go to space if you have the opportunity.
Is it the maiden voyage, though? Like,
no, I think if we're talking space tourism,
it's pretty safe.
We've done it. Yeah,
we did.
Oh, you wouldn't be on the first. I would totally be on the first.
Yeah,
if I could afford that, why not? I mean, to have the experience of, I don't know, being up there, being off of the Earth. We are from this, but to be able, but we're also
go
from
there.
Right.
Yeah.
It's almost even going more home than we are right now.
Right.
In a sort of,
That's a good way to put
logical
it.
way.
Whoa.
Yeah.
Didn't know that's where we were going with this, but yes, that's great.
I
did.
Don't let me talk. Don't let me talk.
Stop. That's funny. All right. Next comment comes off of Reddit from Cap MSFC. That is really difficult to say. The idea that contamination ruins our ability to search for life doesn't make sense to me, and in my opinion, only exists in the scientific community because of the way robotic exploration has been limited to biomarkers. If this is life on Mars, I consider it a necessity that we go to study it in person with all the equipment and processes to isolate contamination from the indigenous life. That's an interesting way of looking at it. I can see that point of like, look, my DNA is my DNA, but you can see the lines of like, this is the part that came from my mom, this is the part that came from my dad to a certain extent. Like, no.
So
no?
I actually no. So for me, this is
no, great.
This one has me going because there's a story from Apollo 12.
You're right. You said don't let you talk. So sorry. I'm totally kidding.
Okay, so the Apollo 12 astronauts, part of their mission was to go to Surveyor 3 and retrieve parts of it.
Yep.
Because they wanted to look at what kind of damage the radiation exposure outside of Earth's magnetic shield, what it was doing to the craft. And so they brought pieces back, and one of the pieces they brought back was a camera. And they found bacteria on the camera.
Okay.
Was it moon bacteria?
I was going to say, they got really excited about it, right?
Right, yeah. So was it moon bacteria? Was it contaminated on its way back? Even with people there, in situ, we won't know if it's Martian life or if it's contamination from Earth. If we, unless it's so drastically different genetically than anything that we have on Earth, which...
Ooh, Andromeda strain style.
Right?
There it is.
Then we might not be able to know. So I think the anti-contamination processes that JPL go through, the clean room build, all of it, I think it is totally necessary. Especially if you think Mars has the potential to be an ecosystem. And if we are just like, whatever, gesundheit, right? On Mars, our bacteria, our germs, our skin cells might be hostile to whatever life already exists there.
Exactly.
So we want to do our best to preserve anything that's there before we just assume there's nothing there, or we'll figure it out when we get there.
Yeah, and I mean, and that was like a huge stipulation too when they, I mean, as Dr. Charles Liu was mentioning the Europa mission, because it's like, oh my gosh, imagine we do discover this amazing, beautiful, complex ecosystem underneath the ice. Oops. And we just destroyed about 60% of it. Oh, shucks. You know, because it is a serious threat there. I mean, we take for granted, like, kind of the complexities of our ecosystem and how, like, you know, like, and as you said, even something as simple as like a skin cell or something biological can like completely eradicate like a certain goodness knows. So yeah, I think it's important to maybe get a little squeaky clean there.
Of course, Jared Head has something to say. No surprise there. Let me just lean over and read all of this for you. It says, no one has any clue what life may look like. The assumption that it may be different, but I can't talk. The assumption is that it may be different, but it also may be indistinguishable from life on Earth, which Sarah said wonderfully. If it is indistinguishable from Earth life, then you are lax on contamination procedures. Then you have no ground to stand on that you found life indigenous to Mars. Whew. Okay, got it.
Yeah.
Wow.
All right. Thank you. Yeah.
He just threw his phone at the window.
So what Sarah and Jade said. Got it. Thank you, Jared. I appreciate it. No. I mean, obviously, all joking aside. Yeah, no. That makes sense. That totally makes sense. If it is exactly the same, but we didn't go through the processes, and we don't know if we found something new or we found something really, really old. And so
that's what I'm wondering, though. If we do find something on Mars, or say, like, if, you know, you said Apollo mission, so that would be the moon.
Yeah.
If there was bacteria found there, wouldn't we know all the bacteria that already exists on Earth, at least have like record of it? How would we know that we found it? Like, if we found something from Mars, wouldn't we be like, well, this is nothing like what we've seen on Earth, it has to be from Mars? Where would that distinction come in?
So that's one of, I mean, yes, that could happen, and we would know. Like, this is Martian. This DNA is not carbon based.
Yeah.
Whatever it is. But if it is similar, and also one of the possible explanations for life evolving on Earth is panspermia.
Exactly,
right?
and that's what I was thinking right now. Then it would be similar.
Right.
So whatever term you just used, I need to hear again, and I need you to explain that to me.
Oh, panspermia. It's as kinky as it's no.
I mean, yeah, kind of.
Right. So it's the hypothesis that life on Earth didn't originate here.
Right.
That the building blocks as we know them, the proteins, amino acids, they came with the comets that gave us our water.
Sure.
And so those same comets would have deposited those on other worlds throughout
because
the
they
solar
weren't
system.
water comets.
Right.
Exactly.
Okay.
So then Martian life would genetically look
similar to Earth
life.
It might have evolved, and it might have even evolved similarly as well. I mean, looking kind of, I mean, just like geophysically at the two planets.
Yeah.
And so that's what I always thought about that too. Like, if we are going to find life on other planets, you know, microbial, bacterial, or otherwise, It's gonna, yeah, you're right. It's gonna be hard to, unless we find it there, like say you have a rover and we find it away from the physical rover versus, oh, it got stuck to us and then it came back.
Right.
You know, then it's like, well, it would be hard to distinguish because they'd probably look very similar, if not indistinguishable.
Yeah, and you know, I mean, we might end up, running across a green alien that's, pew pew. Get this rover out of the way.
Can I be the first one? I want to be the. Oh God, what's his
now
name?
she wants to go first.
I want to be the. I want to be the Captain Kirk of discovering alien species, and
I'll be the Gord.
Amazing. If that doesn't just sum up this cast of characters, I don't know what does.
Very open-minded.
That's amazing. I love it.
I'll be the welcoming committee.
And just Kirk.
Start talking
You're
about.
welcome.
There you go.
All right, moving on. Next comment comes off of YouTube from one Nick Cullen. I'm of the opinion, not sure how popular, that we won't see much in the way of orbital space hotels. Once SpaceX gets the big Falcon rocket flying, the applications it can cover also include cruise ship-like flights. Hardware that has to go up and stay for repeated use has a lot of drawbacks compared to something you send up for a couple of weeks at a time and bring it back down for inspections and refurbishment. Yeah, I guess, right? I mean, that's the whole idea. That's sort of if Ben Credible was here and or listening, and we won't know if either are happening until he disagrees with me in the chat room. That was the whole concept. I think it even actually came up a little bit earlier in the chat room of like, look, that's why we are so sort of like down on the space shuttles. Like it was supposed to be just refurbishable, really quick, go back up. It was supposed to fly multiple times a week or at least once a week, kind of thing. All these different things going on, and that's like totally just not what happened. But if you can get to that sort of point where you do have a vehicle that's as easily, much like an airplane, you do the inspections, you do any sort of refurbishment, a little bit of, paint over here, whatever, and then send it on its way again, then yeah, you can totally go for like cruise ship-like flights, quote unquote here. Thoughts?
Yeah, I mean, I think that them saying that, like, I'm of the opinion, not sure how popular, that we won't see much in the way of orbital space hotels. So obviously, like, that's, to me, like, I feel the same exact way, where it's just like, well, there isn't really a lot that's holding us back from actually doing that because of the accessibility in which we have now with rockets, and we will be having soon, and like very, very soon.
Totally.
So I understand, obviously the drawbacks and the problems, and exactly what you mentioned with the space shuttle program, but I think that, the fact that we had already gone through that and now this is a new era that we've entered, it's just a matter of like just growing on it, and we're constantly building up the blocks. So I think that, I think it's great, and I think regardless, it's going to have multiple applications. It's not just going to be for one thing. Like right now we have recargo missions to the ISS, and there's going to be so many other things that like the BFR will be able to do, and then other rockets that other space companies are going to be having, obviously Blue Origin and Virgin Galactic, and I think that there's going to just be so much more that there's potential for. So, yeah, I mean, your opinion's popular to me, Nick, so I'm in the same boat. I think that, yeah, we won't see much in the way.
Space hotels, yay? Nay?
I think both. Why not have both? You can all have a big Falcon space station.
Yeah.
Right?
Yes.
Come on, we got the ISS up there.
Yes.
We could rendezvous at some point, like meet have dinner with an astronaut for an extra $1 million.
Have the the
space credits, it's fine.
honeymoon suite, and you're looking out that way.
Space casino. Right? Because it's probably going to be unregulated up there, if you know what I'm saying.
Darn tootin'.
Caesar's Palace.
Maritime law would extend up.
Really?
Right, just directly over the over the water. Cool.
It depends what you're orbiting around. Like, well, now we're in Amazonian territory.
So I think a little bit to go against Nick here. I apologize. So you said, yeah, I would go with the first one, not a big deal.
Yeah.
Jade, you said you would go eventually.
Unless she was kirking it.
Right, unless she gets to be Kirk. I haven't ever asked you, would you go?
I would definitely go. I would not want to be the first of just like essentially any mission. Same thing with Mars. Same thing with also suborbital. I would want there to be at least a handful of guinea pigs. It's kind of wrong for me to say. Test
pilot.
Yeah, test pilots. Plus, I really see myself when I'm much older actually doing long journeys to space. Like I when I'm much older, have a family. No.
She's like, wait,
hold on. No, like 80, you know, and like I know maybe like I honestly think that with medicine and technology by that age, I don't think it'll be too much of a concern of the age, to be honest.
Right.
Where now you have someone who's 80 and a lot of people are still extremely fragile, and I think with just injections, different things that elderly people have. Right. I think by the time I'm 80, I don't think it would be that many obstacles to go to space, and if there is, I would risk it.
See, and I don't think I would go. I don't think I would go out for an extended period of time. Really? But like a space hotel.
Yeah.
Like. I'm also very B.A. Baracus. Like, you need to knock me out in order to get there, and then I'm probably okay.
Lots of Benadryl.
It's an A-Team reference, really old time. But yeah, I don't think I would be really good. I'm crap on planes. Like, I'm not really fantastic. Like, I'm okay, and I'm better, but I think the first, like, space launch I do,
What about like
it would be awful
having like surface tension champagne, like little like champagne bubbles. And
that
just,
sounds
like,
great.
drink that.
I'm there.
That'd be great.
It's going from here to there. That's my problem.
I guess
and
I'll be uncomfortable drinking.
I think the idea being like, okay, I can be in a hotel and I can see this. That's cool. That's where I live. I can see that. That's cool. Sure, my friends live there. Like I'm good there in that weird sort of middle space. It's the journey part I think is terrible. That scares the absolute
so
out
you don't
of me.
like the Guardians of the Galaxy ride then?
I like it now, but more than I did. That's a different conversation. But yeah, so for me, the space hotels seem like a perfect middle ground in a weird way. Yeah. So I mean, I don't know if it's popular or not popular in that particular sense, but I think for somebody who's not really great with heights. Yeah, I think that's a really great idea, personally.
And space bike volunteers.
Right. Yes, of course,
I would volunteer for a long-term trip.
Yeah, go ahead, Sarah.
I think you also hit on something. I think long-term life up there, I mean, looking at Scott Kelly's telomeres, right? They grew quite a bit while they were up there. Older people we might have geriatric stations to prolong life. And I'm going to go to the documentary Contact, where
please cite it.
S.R. Haddon, right? If you got all the money in the world, you put yourself in space. It's less damaging on your joints. Your circulatory system doesn't have to work as hard to fight gravity. Maybe there's some potential there as well. It wouldn't just be
retire.
We're going to go.
Retirement homes in space.
Space is the new Florida.
Yeah, it's funny. Now that you say that,
that's what I was thinking. But then Tommy Bahamas and the coconut drinks, and even Johnny Spacer says space hospice or hospice.
Oh, nailed it. Wow. We're going into business right
volunteers.
now.
You heard it here first. We'll take starting bids at $1 billion.
That's $1 billion. One? That's not enough. About $50 million.
Oh my goodness. All right, so next question comes off of YouTube from The Moon is Square, which we could probably even just stop there and discuss that for a while. But
go on.
So there's an actual question. It says, Dr. Robert Brown said Curiosity's Sky Crane landed, quote unquote, with 400 kilograms of extra fuel, which have any plans been made to not waste so much mass by sending less fuel this time? I understand needing extra safety margin, but next time, that is half the actual payload weight lost. Just imagine the benefits of 400 kilograms of extra instrumentation or robustness on the rover. I mean, obviously that question was a little bit more geared towards Kim.
Right.
Yeah.
That one, I mean, that's actually news to me. One of the stories that I've heard about the Sky Crane is that it was on fumes. So this, when I read this, I looked him up, and he was there on the project. So I'm going to take
he would know.
Yeah.
Got it.
So I'm going to take his word. But what I heard is that if Curiosity had not signaled touchdown, basically right when it did, the Sky Crane wouldn't have had enough propulsion left to keep itself above Curiosity and then take off. It would have kind of slowly collapsed onto the rover.
Ooh, ouch.
So, and another thing that happened with Curiosity is the parachute. It was at breaking point. They were so lucky that it didn't tear itself apart. And when that parachute shreds, if you've seen any of the test videos that JPL has released, when those supersonic parachutes shred, they shred. It's nothing. Your rover just becomes a meteorite. So this is, even if it did have 400 kilograms of extra fuel, I'm on board with that, because if anything goes wrong, if it has to pick a new location, if the landing site is a little off kilter, if it's for some reason just beyond Mars 2020's tipping point, I want them to be able to redirect the rover.
For sure.
And if you don't have enough fuel, all of the money that you've spent on your mission,
that's just
becomes a scrap pile on Mars.
Zweeby in the chat room says, if you add 400 kilograms of extra instrumentation, you will have to carry more fuel. So I think that's a really decent point.
Yeah.
It's exactly as Sarah's saying. I think having that little bit of, that's what we call nominal.
Yes.
Right? A little bit of fudge reel on that one.
Nominal.
Right? Great. Okay. So we answered that one. Next comment comes off of YouTube from Old Gamer Noob. It says, speaking of the new space station trend, was Gateway Spaceport mentioned? I'm too lazy to rewind and go check myself.
Love the honesty.
Right. That's kind of funny. If I remember correctly, we are actually having the Gateway Space. I was going to say the Gateway Spaceport, but Gateway is actually coming on the show in a couple of weeks. If it's actually not here in the rundown, so I can't answer that for you. Somebody is going to put that into the chat room for me so that I can read it to you live, but I believe that Gateway is actually coming onto the show shortly. Stay tuned for details on that. So that we can answer all of those questions and more. So now, before we get into what we're doing the very next week, I want to make sure I also still thank our ground support citizens. These are the people who contribute $1 per episode, up to $2.50, and every little bit helps, as we were saying. If you would like to continue making these awesome shows, because we wouldn't be doing this if it wasn't for you. We would be having these great conversations in coffee shops, as Space Mike said earlier. You can always feel free to become part of the citizens of tomorrow. You can head on over to patreon.com/TMRO. And speaking of next week, the incredible Jeff from Fueled by Deathcast, which is the Death Wish Coffee podcast that is going on the International Space Station, is going to be on our show. And guess who's going to be interviewing the incredible Jeff, Fueled by Deathcast, talking about Death Wish Coffee, going on the International Space Station. Who's doing what? You? No, you. No, I am. I am, because it's coffee. Because it's coffee and it's space.
And coffee runs in her veins.
So, coffee talk.
We're going to do some coffee talk.
Space
Bring
coffee.
like an espresso maker.
I totally should.
Space clothes, space and coffee.
Yes, I totally should. Good. Thank you, Miss Jade Kim. John Bilnkel, is that how you say that? From Gateway Foundation will be joining us on Orbit 11.27 on July 7th. But for the one in between, 11.26, I will be interviewing the incredible Jeff. So that's pretty much all we've got for this particular episode. Thank you, ladies. It has been a pure joy.
Thank you, guys.
We will see you guys all next week. Bye.
Bye.
Oh, yes, it was. The thing is that, and now we're talking through this, and he can yell at us for that, and I really don't care. The nice thing is that Ben had said this really cool thing where the mics will, he programmed it in. So, like, if MS, right now we have an MS1 and an MS2, right? Because we don't have a hologram. And so, if you'll see in the thing, it actually says, where's a really good one? Don't mind me. Standard questions. Here we go. Config mics for comments. Right, so then on this side, Commander's on, Capcom's on, MS1 is on, MS2 is on, Hologram, however, is off, Guest is off. And so we programmed it in because we continue to talk over the ending, and it drove Ben so crazy. He was like, fuck this, and he programmed it so now the thing just does the thing. And so now we can talk as much as we want.
Oh, thank goodness.
I love it. Yeah,
That's great.
which is great because that came on and everyone kind of paused really quickly, and I was like, no, it's okay. Yeah, literally, I wish you had seen it because we were all kind of like, no, what do we do? I don't know. You can scratch your nose. I had to scratch my nose. I actually readjusted. Poor thing, his leg was asleep. So sorry.
We're all just reaching that age. It's bad weather out here today, so arthritis is kicking.
My head is freaking pounding. It's just so nice to be like, thank you, ladies, because this is an all-girl show.
This is pretty cool.
That was fun.
Yeah. A lot of fun. Yeah, but this is the best part.
I had no idea, and Carrie Ann was like, "Oh, hey, it's an all-girl show." I'm like, "What are you talking about?"
But yeah, Beth's like, what do you mean it's an all-girl show? I was like, Jade, Athena.
Oh,
Athena. Glitter on them.
Rocky Balboa fighting.
Yeah.
I'm sorry, I won't wear them out.
No, they're so
They're
great,
like
though.
really, really sparkly.
They're so great.
That's so cool.
It's impossible to get rid
Yeah.
of glitter.
Yep. People are going to think we have some wild after parties here. Like, where's this glitter coming
But at
from?
least
Like,
I didn't bring my glitter hairspray. I was gonna do that, but
Yes.
should have brought it to yours.
We always talk about glitter hairspray. We never do it. What's
I'm
wrong
gonna
with
bring
us?
it. I'm gonna bring it next
Dude.
week because I have it and it's gonna go to waste and it's gonna go bad. So I'm gonna
What do you
bring it.
do
We're
with
gonna
it?
spray it. Just spray your hair.
Spray your hair.
Yeah, that's glitter. Yes.
It won't look like
I
dandruff.
like how Miss Cosplay asks
No,
what
it's
you
super
do with
sparkly.
glitter
I
hairspray.
just feel like it made me look like I already have more dandruff than I already have, you know? And it's not a problem I'm looking
It's
to get
perfect
into.
in your hair though because your hair is super dark, so it's gonna be really reflective.
It's like
It'll be
stars in
awesome.
the night sky.
Got
Let me
it.
show you some stuff.
Cool.
Especially if you don't do like. Just like, don't spray it all over.
Right, just get it really close.
One little.
Actually pay attention to the can and hold it 6 to 8 inches away.
Yeah, no, don't do that.
Flash dancing.
Like this is
Amazing.
yes. This is what it would look like. I mean, I guess it doesn't look that great there. There's like other pictures,
right?
But that's the one that I
That
have.
is definitely dandruffy. But if you use it on flowy hair or something.
Right.
Yeah, it would be
Yeah.
like super cool.
Galaxy.
Oh no! Wait, go
Wow.
wait. There was one
Where?
girl. This one.
Whoa! Look how cool that is. So we gotta do this one day.
Totally do that.
Yeah.
Oh, she got the
You have
matching
the perfect
eyeshadow.
hair for it too. Like,
Wow.
it would like all these colors would show on you. It'd be so cool.
Roots just add
That
glitter.
That's great. Oh, look! Look with the beard. Oh my God!
Oh, glitter beard.
Glitter beard.
Glitter beard's a thing. Glitter beard's a thing.
Glitter beard.
With the tiara.
Glitter beard. Glitter beard. Glitter beard.
Oh my God!
This is what happens.
Oh my God! This is. I'm setting this in the chat right now.
That's so
That's setting this right now.
Now, is it actual hairspray or is it just like it deposits glitter on you?
There's two different kinds. So the one I have is spray, but this one looks like it's just loose glitter, and they probably put like a sticky solution on first.
Okay.
But yo, this is amazing. Dude,
That was like a trend a couple months ago.
Whoa.
Where
during
you put a
Coachella and
bunch of
stuff. Yeah, they're all doing that. Dude, I can't imagine eating though with the beard like that with glitter on it. Like the second you eat a burger or something, it just.
Discharger 1701 says, I was going to say how I was like Bennett, not noticing or caring about the gender composition of the show until it was mentioned, but now they're shouting about hairspray. Dude, man, it's hairspray. Shush.
Right?
Oh, man.
So it's like summer camp '98 glitter trends.
Yes.
Oh, what?
Body glitter.
Oh, my God.
And when it was like a gel,
Yeah,
you had to like put it on your bones.
Yep.
Wherever your bones protruded, you put glitter on it.
Bones.
Nowadays you use highlighter, but it's the same shit as glitter back in the day.
Great. Here, I'm gonna look up glitter for men.
Oh, my
Glitter
God.
for men.
Just for men, glitter.
Oh, it'll be cheaper because pig tax.
Wow, this beard.
That
what?
fierce.
That is so cool.
Look at those eyes.
Yeah.
Dude,
Man.
those are like
They match his eyes. That's like
Men
not
love
even fair.
glitter.
That's not even fair.
Okay, I'm sending this. Look at all these beards.
So good.
It's like some did it not that well.
Shaking his head in the corner.
Don't worry, I'm sending a lot of reference shots.
Good.
Look at all these reference shots for
What
your
is that
your
song
I blame for
about?
shorts.
Yeah.
I mean, we can start
imagine
talking
glitter
about beef
mohawk?
jerky if that makes you more comfortable.
Jared.
Glitter mohawk.
Glitter hawk, glitter hawk, glitter hawk.
Jared,
Yeah, he's down. You know he's game. Got it.
Oh my gosh.
This is
Oh, hello.
Oh wow. Don't send that anywhere though. Show Sarah.
I won't.
Don't send it anywhere.
What?
Sarah.
Oh my
I
goodness.
typed in merman and that came up. So
I mean, that could be
Merman.
that's awesome.
And he's the colors of the
love it.
sunset.
It's
He
so
meant
cool.
to do that.
I put this message.
I mean, yes,
It's true.
I'm
I
gonna
mean,
close out of this.
he's obviously into
Ooh,
science.
that's forever in your Google search now. This about that. So we all have to go, right?
Oh,
Yeah. All right.
Basically, our entire After Dark consisted of
And what?
Tomorrow glitter's coming around.
And what?
This is awesome. Like
Glittered.
so cool.
Also, I enjoyed that Dr. Charles was able to make
Athena
blush.
like blush.
Oh,
Wow.
She
Yeah.
had an entire studio for a year off of just her blushing.
That was
Oh
adorable.
gosh.
What if somebody was like changing the RTG into BTG blush?
The thing is, I was in a different chat, and I'm really happy because I was in the main chat, and then I was in like the host chat. So thankfully, I stayed in the host chat because the second I looked over that, I was like, I saw that going on. I'm like, nope, going back to the host.
Yeah,
I was like, I'm gonna laugh too much when I look at this. I was
I
like,
quite
nope.
enjoyed that he was always like this.
Oh, no. Okay. Oh, embarrassment level. Yeah.
So good though.
Glitter hockey say?
Oh, my goodness.
That was,
Jeez.
wow.
I'm guessing those are image links.
Wow. Yeah, I was like, what are all these letters?
Get there.
Oh, it's the Matrix. Blonde, brunette, redhead.
Oh yeah, I see it now. You gotta, it's like those magic eye things. You kind of have to squint a little
Right?
bit to make it.
Wait, what? Are you serious?
No.
I was like,
I love you.
I literally, because I can't see from here, so I thought eventually the middle sentence said blonde and then said brunette, and I was like, oh, I guess it's written. I can't see.
Oh, you're going to read
I don't have good vision, and I'm wearing contacts.
Hey, you know what though?
Like Hubble.
The best part is that once Minnie Stoge, once Minnie Stoge comes back and is directing the show, and we have an all-female on air, we would have an all-female director. Like it would be tomorrow, female.
Bubbles.
Tomorrow.
There's gonna be bubbles and tiaras.
She would rainbow the entire show.
I know.
That'd be amazing.
Lady
great.
Rainicolor.
Like a rainbow back there.
Yeah, you
With
realize
a
you
space
probably
helmet.
can't get glitter in space, right? It'll be
That would be so
It'll
fun.
be a fog concern.
Unless
Space
you're
is its
turning
own
it into
glitter.
It'll be
mirror
a
for
fab
telescope.
concern.
Right?
Would make a very good mirror for a telescope.
So somebody
I think it
actually
would.
had this idea. They proposed sending glitter up. You release it in a cloud, use lasers to reposition the glitter, and then heat the glitter so that it fuses into one sheet.
The science of glitter.
Can
Right?
have
You
some
know what
good
you could do?
defection.
Here's another interesting idea. You could send up just one sheet.
I know, right?
One shiny
But
sheet.
it's so difficult to
glitter
do
mirror.
that. Like it's not.
It's
like,
macro
literally all the
glitter,
way to the
guys.
studio, like,
Macro glitter.
Does that make it
This
glit?
sounds amazing.
It's glit, not glit.
Oh, space station is glit, yo.
That's glit. You say it like that. You know, I'm gonna start using that now. It's
I'm
glit.
into it.
I bet they use that in Brooklyn. But yo, this coffee's glit, yo. I love it.
Cat.
I'm gonna ask my
Excellent. I
friends.
got glitter. I
Oh,
got
you got glitter. You got glit.
He's
He's Jared is glit.
He's part of the
glit.
glit, the glit
I
crew,
love
I
it.
was rubbing in it.
glit squad.
I mean, I know this is after dark, but TMI, man.
I mean, this
so
chair's
yeah.
covered in glitter too.
Unfortunately, we
so
do. We all have to go.
right.
I'm so sorry, guys. This has been really, really great.
Wait, look
show.
at this image.
Athena, that was a fantastic
what?
interview.
There's a
It's over us. It's over us.
Oh, I see it now.
There's rainbow on us.
that
We've
means
been superimposed.
I thought the camera was starting to break. I was like, oh guys, look,
Is the
there's
camera
color
breaking?
defection. Oh no.
Oh, wow.
It's a unicorn. I'm sorry.
No.
Go on.
No.
Resist.
Wish me luck
Continue.
on the interview next week because there's a lot of research I still need to do. It's gonna be bad. It's gonna be
Great.
so good.
You asked me about
gonna
ground
be something.
levels. And
I'm hoping it's gonna be right after the launch. Because the next available day I think is like the day after the interview, so I don't want to like interview and be like, so hope it goes good tomorrow. Like,
And then you jinx.
Oh man.
Oi. In any case, Loopy was saying good luck with Rocket Lab. Rocket Lab, of course, has available launch dates through July 6th, I believe. So good luck to Rocket Lab on that, if and or when they launch. That's really about it. Thanks for joining us, everybody. See you next week. Bye.
For real this time.